Buffer systems. A buffer system is a solution that is resistant to changes in pH when small amounts of acid or base are added. A buffer functions because of the equilibrium that exists between a weak acid or base and its conjugate. By combining a weak acid with a similar amount of its conjugate base, a solution is formed in which the pH depends on the concentration ratio between the acid and the base. In the presence of a buffer, adding a strong acid increases the concentration of hydronium ions, which react with the conjugate base. In keeping with Le Chatelier's principle, the rate of the reverse reaction increases and the equilibrium position shifts so that most of the hydronium ions are consumed. The concentration of the conjugate base decreases and the hydronium ion concentration increases only slightly. This means the pH decreases only a little. As more acid is added, the conjugate base continues to decrease in concentration and the pH decreases slowly. When enough acid has been added to consume all of the conjugate base, the buffer capacity has been reached, and adding any more acid will cause a rapid drop in pH. A buffer system can neutralize an acid or a base that is added to a solution. Buffers are important for maintaining pH in biological systems, such as lakes or the blood of animals. However, the amount of acid or base that can be absorbed is limited by the buffer capacity. Key takeaways. To summarize, a buffer system is made up of a weak acid and its conjugate base, or a weak base and its conjugate acid. Le Chatelier's principle explains how buffer systems resist pH changes by reacting with added acid or base and shifting the equilibrium position. When enough acid or base is added, the buffer system will reach its capacity and the pH will change rapidly.